This standard is about rules of exponents. It has several parts, and it's going to take us a couple days in class to cover this. The first part is the product of a power. So that's what we have here, x to the third times x to the fourth. What's going on here is you're multiplying three x's, so x to the third is x times x times x. And then you're multiplying that by four more x's, x, 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 x. So how many x's do I have total? 3 plus 4. So that's the same as x to the seventh. Writing out all those x's is kind of a drag. An easier way to do it is to go back and look at the original expression and see that you have 3 plus 4, which is 7. So the rule for multiplying two exponents together is that you add the exponents. So let's try another quick example. If we had y to the fifth times y to the seventh, you would keep the base the same, y, and you would add 5 plus 7 to be y to the 12th. So as usual in algebra, this gets harder and harder as we go along. So this problem has a y to the fifth and a y to the second, but it has a 2 and a 6 in it. So what we're going to do is first multiply the number parts. So 2 times 6 is going to be 12. Write down the base, and then add the exponents 5 plus 2. 5 plus 2. So 12y to the seventh. Our next rule is if we have the power of a product. So the product here is x to the third times y to the fourth, and it's raised to a power. It's raised to the second power. So you could sort of think of this as x to the third y to the fourth times x to the third y to the fourth, because I have two of them, and that's what squared means. So I'm going to go ahead and add the exponents, same as I did last time. The two x's have the same bases, and that's important. You can only add the exponents if the bases are the same. So I'm going to take the two x's, and I'll get x to the sixth, and the y to the fourth and the y to the fourth is going to give me y to the eighth. If you look back at the original problem, can you think of a shortcut way to get that same answer? If you multiply 3 times the power 2, that's going to give you 6. And if you multiply 4 times 2, that's going to give you 8. So if you have a product raised to a power, what you're going to do is multiply each of the exponents by the power. So let's try some longer examples. Here I have a whole bunch of things raised to the third. So first I'm going to raise the negative 2 to the third, and I'm just going to write that, I think, negative 2 raised to the third. And then I'm going to raise 5 to the third, x to the fifth to the third, so that means I multiply 5 and 3 to give me x to the 15th. I'm going to multiply 4 and 3 to give me y to the 12th. And there's no exponent written with the z, that means it's z to the first. So I'm going to multiply 1 times 3 to give me z to the third. Next, I need to figure out what negative 2 to the third is. That's negative 2 times negative 2 times negative 2, which is going to be negative 8. So the answer to this whole thing is going to be negative 8 x to the 15th, y to the 12th, z to the third. Now let's combine both of these rules together. First, I'm going to raise a product to a power, and then I'll take my answer and I'll multiply it by the following term. So 2 to the second is going to give me 4, and then x to the fourth squared. So I'll multiply 4 times 2 to give me x to the 8th, and then I'll multiply 3 times 2 to give me y to the 6th. And I still have to multiply that by 4, x, y to the 7th, z to the 5th. So 4 times 4, that gives me 16. And I have to go look for the ones that have the common bases. So x to the 8th, there's no exponent here with the other x. It's like there's a 1. So 8 plus 1 gives me x to the 9th. Y to the 6th and y to the 7th. 6 and 7 add to 13. And there's only this one z over here. So the answer is z to the 5th. Next, let's look at exponents that are divided. So first I'll write all this stuff out. X to the 5th divided by x to the 3rd. That means there's 5 x's on the top and 3 x's on the bottom. You may remember from doing fractions earlier in the year that you can cross common factors out on the numerator and the denominator. So I'm going to get rid of these x's here, and that just leaves me these two x's on the top. So x times x is the same thing as x squared. If you look back at the original two exponents, you could see that 5 minus 3 is 2. So if you're dividing exponents, what you do is subtract the exponents. So let's try a slightly longer one. Once again, I'm going to go through and look at all the bases that are the same. So 8 and 2, those are both numbers. So 8 divided by 2, that's going to give me 4. The next two both have an x, so 8 minus 5, that's going to give me x to the third. And this is like y to the first, so that gives me y to the fourth when I do 5 minus 1. Now let's do another dividing one, except this one's going to come out a little different. We just learned that when you're dividing exponents, what you do is subtract the powers. So 2 minus 5, sadly, is a negative number. I'm going to write this over to the left side because I have other stuff I want to do on the right. So that's the same as x to the negative third. Now, what exactly does x to the negative third mean? Let's do a little bit of work. Once again, I'll write them out like I did in my first example. X times x over x times x times x times x times x. And once again, I'll cancel out the numerator and the denominator. And what I have now is 3 x's left on the bottom. And there's a 1 up here on the top. Remember, if you cancel out 2 over 4, you get 1 over 2. So when you cancel out all the factors on the top, you're left with a 1. So this is the same as 1 over x to the third. So this shows us what the negative exponent means. X to the negative third is the same as 1 over x to the third. So a negative exponent in the numerator is the same as a positive exponent in the denominator. And I won't do another explanation of this, but if you have 1 over x to the negative 7th, that would be the same as x to the 7th. So when you see a negative exponent, you need to take it either from the numerator to the denominator or the denominator to the numerator. And sadly, math teachers don't like negative exponents. They're bad. So whenever you simplify a problem and you get a negative exponent in the answer, you're going to need to flip it and either put it in the numerator or the denominator. Here's another unusual situation. So remember, when you have exponents, you're going to subtract the powers. So I'll write this on the left again. 7 minus 7, that's going to give me x to the 0. X to the 0 is also kind of funny looking. Let's think of some other ways we could represent x to the 7th over x to the 7th to maybe give us some idea what x to the 0 means. Let's go back to numbers for a second. 2 over 2, what would that reduce to? That's the same thing as 1. How about 9 over 9? That's also the same thing as 1. So if you have the same thing in the numerator and the same thing in the denominator, you're going to get 1. And that's the same thing we have up here. It's got variables in it, but still, it's the same thing over the same thing. So that's going to reduce to 1. And the way that it works out, anything raised to the 0 power is going to be 1. Sometimes teachers like to write tricky test questions, something like 3j to the negative 41st, z to the 10th, all raised to the 0. All that stuff inside's kind of scary, but you got a bunch of junk raised to the 0. That just means you get 1. Now we're going to have one more rule about fractions before we start to wrap this up. So x to the squared over y to the third, and the whole thing is raised to the 4th. You can sort of think of the 4 as distributing to the 2 and down to the 3. So that means you can take the numerator and turn it into x to the 8th, because that's 2 times 4, and the denominator and turn it into y to the 12th. If you're raising the whole thing to a negative exponent, remember, a negative exponent means you move the denominator to the numerator or the numerator to the denominator. So I'm going to rewrite this as b to the 4th over a to the 3rd because I flipped them. then I'm going to go ahead and make that thing positive. So that's going to turn into b to the 8th over a to the 6th. So now it's time for one last problem that summarizes all of these rules. So first of all, you need to go through and look and see if you have any products raised to a power, and I do. I have 6x to the 5th y, all raised to the 2nd. So let's get rid of the parentheses. I'm going to rewrite this problem as negative x y to the negative 3rd over 5x squared y to the 4th. Nothing happened there. But 6 squared is 36. X to the 5th raised to the 2nd is x to the 10th. And then y to the 2nd over, nothing happened on the bottom either, 3x to the negative 4th. So now I am going to, well, I've got some choices here. I can either multiply right across, or I can simplify the numerator and denominator first and then multiply across. I think I'm going to simplify the numerator and denominator in each fraction first, because I see that 36 divided by 3 is a nice number. So this first fraction, first I'm going to look at the numbers. This negative, it's kind of like negative 1. So when I look at the number part of this, 1 and 5 don't simplify at all, so I've still got negative 1 and 5. X and x to the 2nd, it's the same thing as x to the 1. So I'm going to subtract the exponents. 1 take away 2 is negative 1. And for the y's, I'm also going to subtract the exponents. Negative 3 minus 4 is y to the negative 7th. For the second fraction, 36 divided by 3, that's going to be 12. X to the 10th over x to the negative 4th, that's 10 minus negative 4, so that's x to the 14th. And there's no other y's, so that's y to the 2nd. Next, I'm going to multiply across. First, I'll do the numbers. Negative 1 times 12 is negative 12. X to the negative 1 times x to the 14th. Negative 1 plus 14 is 13. And then y to the negative 7th and y to the 2nd is y to the negative 5th. And on the bottom, I still have that 5. So remember I said negative exponents in the answer make your math teacher angry. So you're going to have to get rid of that negative 5. And the way you're going to do that is bring the y to the negative 5th, the denominator, and make it into y to the positive 5th. So your final answer, negative 12, x to the 13th over 5y to the 5th.